On page 636, they have the following sum and difference identities. These are on your formula sheets, and these, I think, are the scariest looking identities as far as how big they are. Okay? But I'm going to show you something that we have here. If I have sine alpha, cos beta, cos alpha, sine beta. I'm going to show you with our graphing calculator a little bit of what this means. So if I go to my calculator here and clear everything out, and I wrote sine x cos x plus sine x. It's not a plus sign, is it? Sine x cos x. And I graphed it, I would get this graph. And I set my window up to go from negative 2 pi to 2 pi. In fact, I can even make, yeah, no, my window's all set up that way. And can you see the amplitude is still 1 and 1 here? And if you did dab C backwards, what would this graph be? Does it looks like, well, you can make it a sine graph or a cos graph, but can you see that if I make it a sine graph, I don't have to do a shift? Okay? And between here and 2 pi is right here, I go 1 period, well, 2 pi is actually right here, 2 full periods from 0 to 2 pi. If there's 2 full periods from 0 to 2 pi, can you see that there would have had to have been a horizontal compression? And you would have multiplied, to get 2 periods, you'd have to multiply everything by a half, which seems to be the same as sine of 2x. So I'm going to type sine of 2x into y2 and graph that and see if they match up. And they do. So first of all, I graph this big thing, and it matches up. Next thing I'm going to do, I'm going to say, well, what happens if I changed this 2x to be, this x to be a 2x, so I have sine 2x cos 2x plus, and all I'm doing right now, I should rewrite that one in the right order, cos alpha sine beta. All I'm doing right now is using that formula, I'll just type over top, cos 2x sine x. On the graphing calculator, if you push enter on the equal sign, it doesn't graph it. So now I put a 2x in there and an x, and I look, and I'm like, ooh, there's more periods between 0 and 2 pi. If I count 1 period, 2 periods, 3 periods from 0 to 2 pi. In fact, I can make my window even. Oh, it is going by. Just put 2 pi on there. So then the only mark you see is where the 2 pi mark is. And now there's 3 periods. And so this seems to match up with sine of 3x. And if I graph that, it matches up perfectly. So often at the beginning of this unit, I actually get you to do a bunch of graphing calculator activities where you see the results of these. Since we're short on time, we're going to just have the results here. And these become new identities that if they come up in a proof, you can switch things from the left side to the right side. But more often, we're going to see these used in other applications. Okay? First of all, you have to mostly memorize them. Okay? They're on your formula sheet. And these ones, you're not going to completely memorize them. there would be hard to completely memorize because you might notice that they're awfully the same. Okay? But by mostly memorize, I mean that you are going to say, hey, if I have like sine cos plus cosine, 4 things added or subtracted together, that's probably one of my formulas. So before I do anything else, I'm going to look at my formula sheet to see which one it is. Right? If I have cos cos minus sine sine, hey, that's one of my formulas. Which one is it? I'm not sure, but I have my formula sheet. So that's what I mean by mostly memorize. If you don't have it mostly memorized, then you're going to be just skip over that and not know where to go. Okay? Okay, number one mistake that students like to do is this. Okay, that is never allowed. Sine is a function. You're not allowed to distribute functions. Functions do something. They have a rule, and they don't fall into distribution. Okay, but this is the most common mistake that students have made since grade 9. Do you want to know the grade 9 multiple choice question that's most poorly done? It looks like this. Okay? X plus 3 squared. It says expand. A on the answer key is x squared plus 9. Do you remember that's the number one picked answer by grade 9 students who've done it wrong. What have they done? They've distributed the squared. What does squared mean? Squared means multiply by itself. You have to FOIL this out. It's x squared plus 6x plus 9. But this idea of distribution is so strong within you that you want to do it all the time. Distribution works with numbers. It works with variables because variables represent numbers. It doesn't work with functions. So if you have sine of something plus something, the only thing you could do is change it to the right-hand side of this formula. Yes? Distribute into fractions. So here's like, why am I allowed to distribute here? That the cube goes to this and to this. It just so happens when you say, well, what does repeated, or what does an exponent mean? It means repeated multiplication. And then what are the rules for multiplication? I multiply the bottoms, I multiply the tops. So in that situation, it appears that you're distributing it. But it's a special case that based on the rules of, 2 rules that come into effect here, right? What do exponents mean? And what does multiplication of fractions mean? By coincidence, it also works. Okay? But you can't do this, right? Square root of 9 plus 4 is not equal to the square root of 9 plus the square root of 4. That's the idea of people want to do that. They want to distribute. So you have to be careful that you're not distributing functions. And so in this case, we have a special rule for what happens in a function. So the first question we're going to do is actually number 2. We're going to do example number 2 first. And one of the things that this part of the unit, which starts to look at some bigger formulas and a little bit less proofs, but more applications of these larger identities or these larger formulas. At the beginning, we just have to say, can we recognize them and can we switch back and forth from the right-hand side of an identity to the left-hand side? So for A, okay, express each in simplest form and evaluate when possible. So I look at a sine 8x cos 3x minus cos 8x sine 3x. Does that match up with one of those formulas? This is where the mostly memorized part comes in. You would look at that and say, oh, sine cos, cos sine. I think that's one of them. If this is my alpha and this is my beta and this is my alpha and this is my beta, which one is it? Looks like it's on the formulas up there on the wall. It's the top one. It matches up with sine alpha minus beta. So in A, this is going to equal sine, my alpha is 8x, my beta is 3x. It simplifies to sine of 5x. So I recognize that it looks like one of my formulas. I use my formula sheet to verify which one it is. And it has to match the formula perfectly. If it's a little bit off, you won't be able to use it. And then I'm able to subtract and simplify. Now on your formula sheet, I know at the beginning we did the we looked at the sine and cos ones, but there are also there they are on page 638. There's also formulas for tan. Okay? Strategies for mostly memorizing these. If you have a fraction with a crap load of tans in it, looks like it's one of those formulas. There's your study. That's mostly memorized. I have a whole bunch of tans in a fraction. Maybe this matches up with one of these. So when we go back to this example 2 here, that's example 3. The second one, we've got tan plus tan over 1 minus tan tan. Does that match up with 1? Yes. Tan plus tan over 1 minus tan tan, that's tan alpha plus beta. So again, over top of these I might label alpha, beta, and then think tan alpha plus beta off to the side. Does it match up perfectly? Tan alpha plus tan beta over 1 minus tan alpha tan beta? Yes. So then I can rewrite B as just tan. Alpha is pi over 6, and beta is pi over 12. How do you add fractions? Get a common denominator. Are you okay if I do this 2 pi over 12 plus pi over 12? 3 pi over 12? Is 3 pi over 12 on your pi plate? What happens if you reduce it to lowest terms? It is on your pi plate. It's pi over 4. And tan of pi over 4 is equal to 1. So this one we could evaluate and we could figure it out. So questions 4 and 5 to practice these formulas and practice recognizing them.